we are going to discuss the topic trigonometry. As fascinating as it sounds, trigonometry is a remarkable branch of mathematics. That's because it finds application in various fields like oceanography, astronomy, architecture, and so on. Now, the word trigonometry itself has to say a lot about what it is all about. If we can divide this word, we'll get a better understanding. Tri, gon, and metry. Tri means three, gon means science, and metry means measure. So we know that it's dealing with something with three sides. And we know that a three-sided figure is a triangle. So it is something with triangles and its measurement. But to be specific, trigonometry deals with the relationship between angles and sides of a right triangle. A right triangle is a triangle which has one angle, that is a 90-degree angle. We have learned a lot about right triangles. We know that Pythagoras theorem applies in a right triangle. It is the relationship between the sides of a right triangle. But trigonometry did something very remarkable. It actually combines the angles and the sides. So it gives you a relationship between the angles and the sides of a right triangle. Now, what if I ask you that you have to measure the sides of a right triangle? Well, you would say you could use a ruler to measure the sides of a right triangle. But what if I was talking about a triangle whose sides would be as long as the width of a river or as long as the height of the Qutub Minar? Then that will be a challenging task. So we will have to come up with something better, and trigonometry did just that. Trigonometry helped you to find the missing sides which were relatively longer and figure out an easier way to measure them. Now, say for instance, here we have the monument, the Qutub Minar, and I stand here watching the top. Say for example, this is the Qutub Minar and I stand at a distance watching the top of the Qutub Minar. Then my line of sight, the height of the monument, and the distance between me and the monument all together makes a three-sided figure, that is a triangle. And to be more specific, it is a right triangle. Now, if it is a right triangle, it becomes easy for us to apply the trigonometric ratios and find out a relation between them. Now, if I know this angle, which is easy to find, there are different tools that you can use to find angles. If you know this angle that my line of sight makes with the horizontal, and if I know the distance between me and the Qutub Minar, which is we are able to find that, then we can easily find the height of the Qutub Minar, which is a really tall monument, without actually having to measure it. Now, let's consider a right triangle with one angle 90 degrees, and I'm calling this angle theta. Theta is just a Greek letter that is used to represent the measure of an angle. So if I use this as theta, then we have what is called the opposite side of this angle. Now if this is your angle, the opposite side will be just this. So that is your opposite side. Then the side that is next to theta is called the adjacent side. So that is your adjacent side, where adjacent just means the side that is next to it. And of course we know the hypotenuse never changes on it. The hypotenuse is always the side that is opposite to the 90-degree angle. That is the longest side of the triangle. Now, the trigonometric ratios give you a kind of comparison between all the sides of the triangle and the angle. To start with, we start with the first three trigonometric ratios. They are sine theta, cosine theta, and tangent theta. Now let's see what sine theta is. Sine theta which is also called SIN in the abbreviated form, whereas sine is the opposite side by hypotenuse. So this is your angle theta. I'm talking about the opposite side by the hypotenuse. Cosine, also called cos in abbreviated form, is the adjacent side by hypotenuse. And tangent theta, which is also called tan theta, is opposite side by the adjacent side. So these are the first three trigonometric ratios. There are three more to go, which are just the reciprocals of the ones that we have just learned. So let's see what they are. Here we have cosecant theta, secant theta, and cotangent theta. Cosecant theta is the inverse of sine theta. So if sine theta was opposite side over hypotenuse, cosecant theta is hypotenuse by the opposite side. Secant theta, on the other hand, is the inverse of cos theta. So that will be hypotenuse by the adjacent side. And finally, tangent theta, which the cotangent theta, which is cot theta, is 1 by tan theta, and that is adjacent side by the opposite side. So these are the ratios which help you to find different sides, different parts of the right triangle. Now we can consider the first two ratios that we learned. We learned the sine theta and the cosine theta. Let's write a mathematical thing over here. I know that sine theta is opposite side by hypotenuse. And I also know that cos theta is adjacent side by hypotenuse. Now, if I divide these two, I can easily cancel out the denominators, they are both the hypotenuse. Then it gives me opposite side by adjacent side. Now that's something very interesting. We have already seen opposite side by adjacent side is nothing else but tan theta. So we have this is equal to tan theta. Now we have a relation that connects cos, sine and tan. So we have sine theta by cos theta is tan theta. Now you could also think, how about just doing the reverse? How about dividing cos theta by sine theta? So we will have then the adjacent side by hypotenuse on the numerator, and we will have the opposite side by hypotenuse in the denominator. Here again the opposite sides and the adjacent side will remain, hypotenuse can cancel. We end up getting adjacent by hypotenuse. Now adjacent by hypotenuse also we have learned earlier is the cot theta. So this is cot theta. So now we can also relate cot theta to cos theta and sine theta. So we can come up with something very interesting, different relations like this. Now say for example we have a few more to go. We can consider sine theta multiplied by cosec theta. Now we have learned that cosec theta is 1 by sine theta. So I'm going to put the value there. I have sine theta multiplied by 1 by sine theta. And the sine theta can cancel here and it gives you 1. So that's a relation between sine theta and cosec theta. If you multiply sine theta and cosec theta, the answer will be 1, provided the angles are the same. Then we have cos theta multiplied by sec theta equal to, let's see, this is cos theta. Sec theta is nothing but 1 by cos theta. So we can write that as 1 by cos theta. Now when you cancel the cos thetas over here, we end up getting 1. So that's again a relationship between cos theta, sec theta. And finally we have tan theta multiplied by cot theta. Now when you multiply tan by cot, we have tan theta, and we know that cot theta is 1 by tan theta, which again cancels and gives you 1. So these are the three interesting ratios that we could figure out from the basic ratios of trigonometry. So using all these, we are able to find different parts of the triangle just by knowing maybe an angle, a side. That's how trigonometry makes it all easy.